Hi software engineers, great to have you back for another video. Today we're going to be talking a little bit about software construction, specifically getting into the idea of what an integrated development environment, what source control management is. So in the last video I talked about what is software engineering. We talked about how it's more than just programming, it's all the stuff that goes around outside of the programming as well. Things like how do we know what the user needs, how do we know what the user wants, all the way through how do we perform maintenance. Well, still part of software engineering is, well, how do we work together as a team and how do we work as effective programmers? So the word software construction, we're kind of overloading it a lot here. So if I'm talking about engineering as the entire discipline, with all the phases of development, when I'm talking about construction, I'm talking about the actual building. So this would be the implementation part. With some other DevOpsy stuff kind of thrown into it. So the building, testing, and technical production of software. I mean, there's probably been plenty of programs you've written where you've just opened up a notepad and just kind of did something and whatever, that's great. When you're building large pieces of software, you can't. I mean, I guess you could, but you're kind of asking for trouble there. So when I'm talking about software construction, I'm talking about a rigorous, systematic way of building software. Now, some of the techniques and tools when I'm talking about that could be things like, your coding standards. So, in Python, you want to make sure that you are not using camel case. That's a Java thing. Don't use that in Python. In Python, we'll use underscores or whatever it might be, right? Or you're always refactoring. So the idea that whenever you see code that could use a little tweak, could use a little polish just kind of here and there, make it a little nicer for the next time you're running it, that would be great. This could be something like you see some variables where it's x, x1, x2, x4, fix that up. Collective code ownership and continuous integration, the idea that everyone on the team can work on the code and is constantly being built, and the idea of a minimally viable product, a minimal shippable product, means that in your code base, you always have something that runs. There's always something you could hit play on and it does something. So from a technique standpoint, that's what we're talking about. From a tool standpoint, there's a lot of things that go into it. There's integrated development environments, IDEs, source control management, which will be the two things we talk about the most here. Bug tracking, requirements tracking, communication systems, continuous integration systems. These are all things that try to help larger team or even smaller teams keep on track. Make sure that you're covering everything that you need to cover. Make sure that you're not forgetting anything. It's like those nice to-do lists. Well, Todoist or Trello, some of these other tools, well, those are definitely things that we would look at as far as things that could appear in the production environment. So let me explain why we care about these tools. So imagine that you're going into a new internship, a new job, whatever it might be, that you're joining a team, right? I don't know what your experiences have been like. Mine have been whenever I joined a new team. So for instance, when I was at IBM or was at Wachovia, which is now Wells Fargo, but it used to be Wachovia. But regardless, whenever you joined a place, you took a crash course effectively for 1 or 2 weeks in, here's how we do things. And I know you might have done things differently wherever you were before, but this is the way we do it. This is one reason why we don't necessarily care, hey, are you learning exactly how to use Eclipse? Are you learning exactly how to use Xcode? Are you exactly learning it? Yada, yada, yada. I mean, there are some tools that are pretty standard nowadays, like Git and using GitHub, although you might not even be using GitHub. You could be using GitLabs or some other implementation. But you need to know what the tools are, as in like what category they fall in. So when you show up at a job, you get that crash course, you have the ability to say, okay, this is a new IDE. I haven't used it before. That's fine, but I can kind of understand what's going on here. So those standardized sets of tools are important in an organization because then they can onboard people more easily. And also, if you have problems, you can go to the tech support there and they can help you with it. And also there could be licensing reasons. There could be parts of a license that say if it's built with this particular tool, there are limitations. There's actually a lot more reasons that you need to play nice with organizations when they say this is the tool set you need to use than you might necessarily know. Now, it is true that on smaller teams, particularly more agile teams, You might have a little bit more freedom to kind of use what you want. That also correlates with teams that have more senior, more experienced developers on it, because they might not necessarily need any more assistance. And by gosh, they've been using Emacs since forever. And if they can't hit left bracket inner space, I don't know how to use Emacs. Apparently you smash your face on a keyboard and somehow new software comes out. I don't understand it. I don't really understand Vim either. I mean, I have to have something to edit my server files, but whatever. So anyway, typically newer team members or less experienced team members aren't really given this opportunity. But what are we doing? Here's a basic layout of what our stuff's going to look like. You're probably going to want to use either VS Code or PyCharm as your integrated development environment. Admittedly, VS Code is more of just an editor that has more stuff thrown on it, and PyCharm is more of an IDE that's going to have more Django stuff built into it, spawn the server inside of PyCharm. They're both really good options. Are we going to force you to use either one or something else? No, we won't force you into a particular development tool for this purpose, but just know that these are the ones that we're using. Now, past this point, we are going to force you. Everyone's going to have a private GitHub repo for your team that the staff can also see, where everyone is you're going to keep your code there for your project. Whenever you push a new version, we're going to talk about that means a little bit. Whenever you push new code up, we're going to use Travis CI, which is a fantastic continuous integration system that will take your code and build it and run all your tests. And if it passes all your tests, then it's going to push it to Heroku. And Heroku is a cloud hosting service. So your web app will be at something.herokuapp.com, and that's how you'll actually have a production version of the software that people can. Now, we have other tools, obviously, that we're using in the course. We're using Discord a lot. We're going to have some Google Drive folders for all the teams where you can keep versions of your documentation. GradeScope is used for submitting, collab. I mean, the list goes on, and we recognize there's a lot of tools to keep up with. The previous slide talks mostly about what your project is going to be like. So now let's dig into integrated development environment. Why do we even care? I mean, what does it matter that we're using something like this? Well, here's the best analogy I got for you. What do you use to write a term paper? Think for a second. The last time you had to write a paper, what did you use? Why did you use it? Did you use it just because it's there? Did you use it for some specific reason? Could you have written your paper in a notepad? Like text edit? WordPad? Good. Would it be painful? Probably. There are reasons that we use tools that have other helper tools around it. An integrated development environment is effectively like Microsoft Word for writing programs. Hand wavy, in general, right? Because an integrated development environment is going to try to take away some things that are in your cognitive load at that moment, right? So your cognitive load, what are all the things you could be thinking about at one moment, and how's that affecting how you are performing as a programmer? So if you are concentrating a ton on, okay, do I have all my curly braces right, and my spacing and all that sort of jazz, which is good to do, certainly. But if you hit play at the end, if you go to a terminal and you run it and it's broken, well, now you have to go back and try and figure out where my problem was. You're not thinking about the solution. You're not thinking about the problem you're trying to solve. But if an IDE can say, yo, that ain't gonna work, and it gives you the red squiggly line, like we're now programmed to know that that's what that means, there's a problem, you can go fix it. Also, it'll do things like code completion. If you know that you are going to use a particularly long named function, like anything for an iOS app, my gosh, Objective-C code has long function names. Anyway, so if you know the function is going to be will open in background when phone is turned on, it's nice to type will open and it just does it, so you don't misspell something along the way. Again, it's taking away some of that burden. Then also, if you can do all of your compilation and running and debugging and testing and import libraries and everything inside one program, that's a reason we want to do this. IDEs are really nice. They are meant to help you. It's not, you're not some sort of coding savant because you're like, I'm not going to use Eclipse. I'm not going to use Visual Studio. I'm not going to use PyCharm. If I don't write my code with ones and zeros, that's it. I just need a keyboard, ones and zeros, and that's how I'm going to write my entire program. That doesn't make you elite. That makes you wanting to give yourself more work. And typically in software engineering, we want to make products on time. So the first IDE was actually developed for the basic programming language quite a while ago, and the system was called Maestro. And the reason it was called an integrated development environment at the time was it was everything. It was a monitor, keyboard, system, programming software. It was like, you bought the package. So that's why it was an integrated development environment. The term still works now because now we're just integrating tools, not the monitor. But that's how we got around to the naming. If you search for most used IDEs, you tend to see right now that the two most used are Eclipse and Visual Studio for obvious reasons. There's tons of Windows development, and Visual Studio is a very mature product that does a ton of cool stuff. And Eclipse is kind of your Swiss Army knife for basically everything else. There's a plugin for Eclipse that does anything. The other IDEs you might have used include things like Xcode or NetBeans or anything from JetBrains, which are things like PyCharm. And I have different feelings about all of them. I think Xcode is an absolutely gorgeous piece of software. It's something you open up and you just want to sit down in a coffee house with a big old cappuccino and put on a beret and just like, I will now make the most amazing social media post while then creating a new breakthrough mobile app. And then 10 minutes later, you want to throw the MacBook across the room because you didn't know you were supposed to drop 7 menu levels down just to change one XML file option so that your program will run. I have strong feelings about Xcode. Beautiful program, frustrating at times. The PyCharm product or the JetBrains products are interesting because they all look exactly the same. They just use a different language. So those are fun to play with, and you can get them for free with your student license. Now, picking up a new IDE typically isn't a problem for developers. Once you've learned how they kind of work, you can kind of work your way into it. You might get grumpy if it doesn't have dark mode immediately, but typically they can be customized and you'll be good to go. So those are IDE. Now let's jump into source control management. Source control management is incredibly important if you are working with greater than 1 people on your team. And frankly, you should be using it even if you're by yourself, because it gives you an incredible amount of safety for when you're writing your code that you're not used to. So first, let's talk about working with other people. Think back to when you were in CS2, CS1, whenever you happened to have a partner for the first time. How did you share your code with that partner? Did you, I don't know, put it in an email and email it back and forth? Did you drop snippets of code into a chat window? Did you take snippets of code and don't tell them where it was from and put it in a chat window? Did you get extremely upset with this other person? Probably so. Source control management is what allows you to not do that. And also does wonderful things like keeping backups of everything that's going on. So if you're by yourself and you're working on your own personal project, I still highly recommend that you do it with source control. Because once you set that up and you get to a point that you're like, okay, my software is good now, and then you find out, whoops, that now ain't right. I want to roll back a week. I want to roll back a day. Then you have the ability to do that. So that's why you do want to use source control management. Now, it allows you to have multiple people working. And what's key about it is that if there are any conflicting edits, the different version control systems have different ways of allowing you to merge that code together. So if, for instance, you're working on file A and I'm working on file B, and we both add our code to the source control system at the same time, the system goes, ooh, and just kind of adds them. But if we're both working on A, it'll go, what? Here are the versions. Someone make a call. And that's very handy. Now, there are tools that help you do that too, but you can also do it manually. When you have a source control system running, it keeps historical versions of your project. So you can go back to a timestamp, a particular time that you have saved the code, which we'll call a commit. And if you're also using a system, cloud-based system like GitHub or Bitbucket or any of the other hosting entities, then you also have it backed up. So you can work on it from any machine. What's really great is there are a lot of in-browser editors now that will pull code from these services and let you edit in browser and still save, and it's fantastic. So tons of great stuff you can do here, tons of things that will help you be a better developer. Here's some examples of some source control management systems. Some you know, some you probably never heard of, like CVS. Not the drugstore concurrent versioning system. CVS has been around for a very, very long time. You really don't see it anymore. Subversion, that was the hotness when I was an undergraduate, and that was when SourceForge was really doing its thing. Subversion is fine. It's still out there. Git and Mercurial were kind of the newest ones on the block, and Git has kind of won that battle for the most part. And then there's others like Bazaar, LibreSource, Monotone, and there's even more out there. There's proprietary ones from Microsoft, proprietary ones from IBM that you may or may not ever run into in your life. But in general, we can break a source control management system down into two large categories: distributed, centralized. Okay? Now, why do we care how this works? Well, the older systems were centralized. So things like Subversion and CVS were centralized. And the newer ones tend to be more decentralized or distributed, like Git and Mercurial. And the key metric here is how many repositories are there? And some people might say, but Sherriff, there's only one server. Where it gets kind of weird. And here's what I mean. Let's get the definitions first. What is a repository? A repository in a source control management system is, well, it's where you keep track of the changes. Are there files stored there? Probably. Yeah. But then you might not have all the versions of the files. It might have, diff files showing how files have changed over time. Basically, a repository just needs to have the ability to recreate files at a particular timestamp. Now, the repository is not where you actually make changes. The working copy or the working tree, or there's a bunch of different possible names out there, that's where you're making changes. So you have your working copy, and this is where you're editing, you're building, you're changing. And then whenever you're done, whenever you're like, I've passed all of the tests I need to pass, I feel comfortable with this code, that's when you do a commit. And a commit is, in effect, like save. If that helps you, that's like the save button. Yes, you'll be saving to the disk, but this is like save to the repository. There's an extra step typically. So let's explain how that works. With a centralized source control system like Subversion, there is one repository, okay? And that one repository tends to be on a server somewhere. If you want to make changes, you do a checkout. Tends to be the word that's used. A checkout from that centralized repository. That code comes down locally. That's your working copy. And you make changes, and now you're going to do a commit. And when you do that commit, it actually commits back to the server. Okay? If there are any conflicts, you get a conflict. You get an error message. You have to do the merging. Yada yada yada. Whenever you want to, before you do a commit, you tend to want to do an update, pull all new changes to make sure there's nothing weird that's happened. Then you commit your code, and it just kind of goes back and forth. And you can see on the diagram here how this basic. Okay, now distributed increases the number of repositories. So there is a single repository that's on the server that's considered the origin. This is a term that you see in Git, GitHub. And that origin is considered kind of the main repository. Okay. Now, when you pull it locally, you don't use the word checkout. You use clone. Now, just think about that from just a perspective, right? In checking out, it's like you're pulling it down. In clone, I'm copying it down. Semantics, but it might help you. When I'm cloning the entire repository. And so I have an exact copy of what is in the origin repository that I can work on locally. When you're local, you also will then have a working copy. It could be the exact same directory-ish. Sometimes a repository is a hidden subdirectory. I'll show you that in a minute. So then you start editing. You commit, but that commit happens locally. Okay, that commit is happening locally. It is not happening on the remote. It's not happening on the origin. So you're not seeing any new changes from other people. You at some point have to do a pull to get other people's changes. And you have to, once you've done all your commits locally, you have to do a push to get it back up to the server. So there's more steps. Commits happen locally in a distributed, and then you have to push back up to the server. Whereas in a centralized, a commit goes back up to the server. It's an extra layer, but it actually helps a lot. It allows you to do a lot more things where you can basically build out brand new versions of the system locally without affecting anything that anyone else is doing. So in Git, you work with a working copy locally, and you can create a new one by using various command line commands, or you can use tools to do this, git init, and it creates this folder .git. I'll show you that in a second. Or you could clone from another server. In the working tree, once you create a new file, it's not immediately under the control of Git. We need to then add it so that then when we commit it and then push it to the server, it then actually moves up with it. So the terms you need to know are things like clone, when we're going to pull down a repository, make a clone locally, fetch, getting the new versions, pull, when we pull the new code down, push, when we push our changes back up. So your workflow should look something like this. You fetch the new code. If there's new branches you're working with, you merge those in, you start coding, you commit locally until over and over and over until you feel good with where your code is. Then you push it back up, or you make a pull request, which is a GitHub thing, and then you kind of go from there. So let's actually look at how some of this works. This right here is an example repository I made. You can see the link for it right there. It's public. You can go see it. It's not exciting. But this is an example repository that I made on GitHub that we can play with for a minute. So there's this git ignore file. This is a very important file because if you don't have it, you're going to check in a bunch of extra junk to your repository that you don't want to be there. When you create a new repository in GitHub, it actually gives you the option of saying, well, what type of language are you going to use? And it will automatically generate this for you. So for those of you looking here, there are things like, hey, look, Django stuff. That's stuff that you don't necessarily want to go up to the server. But in general, look, PyCache or a .class file, or these things that are built. We don't want those to go up to the repository. They're not important for the building of the system. In fact, if other people are building the code, their system's going to want to create their own files as well. So in general, you want to block those from being stored. Log files, don't want those up there. Those are useless to other people. Don't want the compiled files. So the git ignore file is super, super important. readme.md, the markdown file, that's just this right here. That's something that's very GitHub specific, but having that markdown file is nice. Then I have my very exciting, hey look, Sherriff can code. Here's what I'm going to do. I'm going to click here, this down arrow code, and I have this git command. I'm going to copy that. And now after I do that, I'm going to jump over here to Ubuntu inside of my Windows machine. So I'm just in my root directory. Now I'm going to, let's clear that and change directory over to GitHub, which is going to be my working directory for this. And I'm going to do git clone and paste that. Now what this is going to do is it's going to do a checkout. Excuse me. Woo, that was subversion. It's going to do a clone of that repository locally. Now, I have already installed Git into my system here, and it already knows who I am, and I've set up things like SSH keys, which will point you to some tutorials for how to do that. But this is not going to make me put in a username and password. It knows who I am, so it does it for me. So I do an ls here. I see that folder. Let's go over to it, and fantastic. Let's actually clear that. So we're just looking at what we have. And because of the setup that I have, it actually shows me that I'm on the master branch. I have my readme file, my hello.py file, and actually I can do dot. It shows me getting. What is that other directory there? Let's go in there. Inside of the .git directory, we have all sorts of interesting things like the head, the branches, config. Never touch this directory, please. This is actually the repository where a lot. Whoops. I went back to me directories. this is where it's going to store all the information it needs to rebuild previous versions of your code. So let's look at a very simple version very quick. So I'm going to do vim hello pi, and instead of saying hello world, I'm going to say hello CS3240. That's not an exclamation point. Right, quit that file, and look. Now, in this instance, it's showing me that star beside master. Again, this is just my setup. You probably won't have this. Showing me that there are uncommitted changes in this directory. So I need to do git commit message new change. I forgot to add the change. Git add, excuse me, I can do add star, and that adds all the change. Now I'll do the commit. So what it was saying right there is, hey, bud, you made some changes to a file, but you did not put it into like the folder called commit. Folder is an overloaded term. You didn't put it in the list of files you needed to commit. My fault. Skipped a step. I don't always do this from command line. So anyway, one file has changed. Now I'm going to do git push, and that will now push the new code up to the server. Very exciting. I can now come over here, hello.py, and indeed it shows me hello CS3240, and it shows that that was the last thing that I committed. That was the comment that was made. I need to refresh this. New change 43 seconds ago. How exciting is that? Now let's try something a little different. Let's say you're working on a team for some reason, and on that team you have the master branch, which, by the way, GitHub is going to be changing the word master to something else, to something like primary or main or something like that, which I think is super good on them. Good for them. For now, it's still called master. So master branch should always be something that's that minimally viable product, something that always builds, something that you point the customer to and say, look, hey, we did stuff. But now you are going to go off on your own and you're going to build something brand new feature. Awesome feature. I'm making a new branch called awesome feature. Okay. I just realized I did not have this up when I did. So here what we can see is, as I was pointing out that you couldn't see because I didn't switch over, because if I was in a lecture, you would have pointed it out to me, that new change. Very exciting. Shows you the change that I made. That was the change. Go, Sherriff, go. Very exciting. Okay. Now I've made a new branch right here. Awesome feature. That will allow me to do some stuff on my own, like I was just. So, or on me for not switching scenes correctly. I'll switch. So now back over here in this scene, I'm going to say git pull, get all the new cool stuff. Git switch awesome feature. I am now in the awesome feature branch. In the awesome feature branch, I'm now going to say vim cool.py print I am cool. I'm having problems hitting the exclamation. I have a new file. That's very exciting. Add cool.py. Git add cool.py. Awesome. Git commit -m. Cool. Git push. Cool. Go back over to my browser. I remember to do it this time. All right. Ooh, it's had recent pushes. Refresh this page. Awesome feature has a new file, cool.py. Switch branches to master. Not there, which it shouldn't. That's exactly what we want. So what branching allows you to do is it says, okay, I can create an alternate reality, so to speak, that I can build my code into a whole new feature without affecting anything on the master branch. Now, when I'm done, compare and pull request. Cool new feature. This is super cool. Create the pull request. It's going to check to see if it can do the pull merge automatically. There's no conflicts. Thank you, GitHub. merge that pull request, confirm the merge, and now it is done. I can go back to the master branch and cool.py now. That's how this works. You might not want to do all of that inside of the command line. Matter of fact, I hate doing it all in the command line. I'll use something like VS Code. So right here, looking at VS Code, this is actually the code for the course website, as I've been desperately trying to get the schedule finished. And I have a master branch, and I can click on that, and I can see if I have other branches. But maybe let's do this. I'm gonna open a different thing for another website that I work on. So this is for a conference, okay? And I click on the master down here in the lower left-hand corner, and I see that I've got a dev branch and a virtual branch and a Sherriff content branch. And so I can do all of my GitHub stuff from inside of VS Code. Matter of fact, let me actually switch back now to the course website. So I actually have some changes here. I can click on this button here on the left, the source control button. I don't want to do anything with my gem file. Discard those changes. Thank you. But I do want to save those schedule changes. New schedule changes. Make the commit. That was the plus. And then down here, there's this little up arrow, which is going to push the changes up to the server. I'm not going to hit that right now because I probably need to make a few more changes before I do that, but know that that's available. You can also use other tools like Git Kraken. So this is a neat one. This is that other website that I just showed you that visually can show you who has made the changes. So here's Mark. This is my friend Alvaro. And then this is where I branch the website into dev or into virtual. And then here's the dev change, and we merged it back into master. And you can go back and see how the website has changed over all this time. Source control management is pretty awesome. Is there a lot to learn? Yeah, and you have to kind of get used to how all this works. But whether you're doing it through the command line, or you're doing it through Git Kraken, or you're doing it through VS Code, it's a great thing to learn, and learn it early in your career. So that's what I've got on software construction for today. I know there's a lot here that you need to dig into and work on. We're going to post some example code. We're going to post an early activity for you to go in and start working on Git. I promise you'll pick it up. It'll work out great. Something to sink your teeth into here at the beginning of the semester. And then we'll start getting in on requirements and getting into the rest of the semester. So thanks so much for hanging out. I hope this video has been useful. Let me know if you have any questions. Drop them in Discord. Send me an email. Great having you. As always, talk to you later. Bye.